Hello, friends, a podcast to talk to you about rationalizing fractions that have radicals in the denominator by using a conjugate. So those are all terms you should know. So, as a reminder, all right, the goal of rationalizing is to get the radical out of the denominator. To do that, I am going to multiply this whole expression by 1. But the one I'm going to choose is going to be the conjugate of the denominator over itself. Because remember, anything divided by itself is 1. So this whole term here equals 1. And multiplying by 1 doesn't change the number. But what this will do is get the radical out of the denominator. So when I do this, on the top I'm using the distributive property. 3 times 4 is 12. 3 times negative root 5 is negative 3 root 5. So I just distributed the 3 across this whole expression. Now on the bottom you should recognize I'm foiling. So when I multiply the firsts, I get 16. When I multiply the outsides, I get a negative 4 root 5. When I multiply the insides, I get a positive 4 root 5. And of course, those things will cancel out just like they do in difference of squares. And when I multiply the lasts, I'm going to get positive times negative, which is negative, and root 5 times root 5 is just 5. So when I go to simplify this, I should recognize that this and this cancel out. And that leaves me just a 12 minus 3 root 5 over 16 minus 5, which is 11. And that's it. That's my answer. Okay, so what do you got to know? I got to know what a conjugate is. I got to know that rationalizing means getting the radical out of the denominator. And then I got to know how to actually execute using distributive property and foiling. All right, so you should be able to do this. I showed you in class, showed you another one, so you should come in tomorrow ready to rationalize using conjugates. The other thing we spent time doing in class today was solving equations that look like this. And remember what I said is to treat this whole expression here, this squared expression, as if it were an x. So let's just walk through this problem as if this was just 2/3 x minus 66 equals 0. So this should still be easy. This is from the fall when we were doing stuff that wasn't quite so difficult. If I add 66 to both sides, I'm good. And then remember, I multiply by the reciprocal to get these to cancel, but anything I do to the left, I got to do to the right. So I multiply this by 3/2 as well. And the 2 cancels the 66 down to a 33. So then I get x equals 33 times 3, which is 99. Okay, so that I should already know how to do. So I'll just leave that there for a second. And what I want you to notice is when I do this one, I'm going to do the exact same steps, except at the end, instead of having an x, I'm going to have an x plus 8 squared. So I'm going to add the 66 over, and that's going to leave me just this bit equals 66. I'm going to multiply by the reciprocal, which just like the other example is going to give me x plus 8 squared equals 99. Then I'm going to take the square root of both sides. And remember, when I take a square root of a number, I have to consider the positive and the negative. So I'm going to get x plus 8 equals plus or minus root 99. And then I simply subtract the 8, and I get x equals negative 8 plus or minus root 99. Now, if you're getting to here, I'm thrilled, but you should also recognize that root 99 breaks down, right? I can rewrite root 99 as root 9 times root 11, and that the square root of 9 is 3. So negative 8 plus or minus 3, root 11 is the simplified answer. So this is good, but this is better. All right, see you in class tomorrow.